The deal here is you need to be able to take a function that's presented to you in one way and describe it in one of the other ways. There are 4 ways to do this, right? 4 ways to describe a function. One of them is verbally, one of them is with a table, one of them is with a graph, and one of them is with an equation. Here, you're being presented with a graph. If you look carefully, you can see that at 0, the value is 1. At 1, the value is 2. At 2, the value is 4. At 3, the value is 8. What kind of sequence is this? 1, 2, 4, 8.
It's geometric.
Right, it's geometric. Okay? It's a geometric sequence. And how do you know? And what is that term?
2.
Okay. So those are the 3 things you want to make sure you say. Right? It's a geometric sequence. You're multiplying by 2. That's your common multiple, your common factor. So which one of these is it? Linear or exponential? Exponential. Okay. Now the question is, can you write an equation for it? Well, the way an equation works, the whole point of an equation is, if I tell you a number, you can figure out what the value of it is. Okay? So just as we said, the number 0, the value is 1. The number 1, the value is 2. The number 2, the value is 4. What does that sound like to you? Okay, f of x is equal to 2. Well, it's not always equal to 2, is it? No. But it always seems to be some factor of 2. So what happens from here to here? Yeah, if this is where it starts, right? This is where it's multiplied by 2. And this one? So it's 2 times 2. And this one? Anybody see a pattern? What is it? Right, what do we call that? How do we write that? Yes, exactly. To the power of x, right? We have repeated multiplication, and we write repeated multiplication as an exponent, which, by the way, makes it an exponential function. So as soon as you knew there was an exponential function involved, you kind of have to figure that in the function that you write, in the equation that you write, there is going to be an exponent. Now the question is, what is that exponent? And in this case, it's just whatever level this is, right, whatever term this is, put that as the exponent, and that will give you the value over here. Even going this way, if I put 2 to the negative 1, what's that equal to? 1 over 2. Okay? Here's negative 1, and sure enough, you go up 1/2. Okay. So that's the answer to this one. That's what I was looking for. That's the kind of thing you have to be able to do. Okay? All right. Now, here, we've got a table. And this keeps going up by 2's. But let me ask you this. Can you figure out what the number in between each one of these is? In other words, if I wanted to see what term went with negative 1, what y went with negative 1 equal to x, can anybody figure out what's supposed to go in there? Yes. What kind of sequence is this? Arithmetic. Okay? It's an arithmetic sequence. And what's the difference between each one of these numbers? What's the common difference? Subtracting how much?
18.
Okay. So it's negative 18 is my common difference. But I'm subtracting negative 18 for every 2 here. Is that right? How much do you think you're changing for every 1? Negative 9, right? So the common difference is negative 9. Because the question is, what's the difference between each one of these? And we're looking in between here. So, if it's an arithmetic sequence, what kind of function is it? If it is an arithmetic sequence, it's a linear function. If it's a geometric sequence, it's an exponential function. And the graph for an exponential function looks like this, and the graph for a linear function is a line, a straight line. Yes?
So for the first one, would you tell that it's exponential just because the line is not straight? It's not.
No, there are other nonlinear curves. There are other, I mean, here, this isn't straight, right? But it's certainly not this, right? Or this, the one we were doing the other day, that's not straight, but it's not exponential. Okay? Anybody remember what we called this one the other day? It's a parabola, right? And what kind of function is it? Yes. Yes, exactly. It's a quadratic function. Okay? So anyway, so there are more than just these two types of functions. These are just the first two you're being introduced to. Now, as an equation, let's see, what's happening here? Okay, let's start with this. What's the one that goes to 1 when x is 1? That's a better place to start. That'll make our lives a lot easier. Right? If x is 1, what's y going to be? Negative 4. Okay. So now, if f is 2, we already know that that's going to be negative 4 minus 9, right? And if f is 3, it's going to be negative 4 minus 9 again, right? If f is 4, it's going to be negative 4 minus 9 again, minus 9 again. You see the pattern? You're subtracting over and over again. What do we call that? If I'm adding the same thing over and over and over again, you're multiplying. You remember that? Yeah. So if I'm subtracting 9 over and over and over again, I'm multiplying by negative 9. Okay? Okay. How many times am I multiplying by negative 9? Well, take a look here. Right? I'm doing it not at all when x is 1. Right? So not at all. Then I'm doing it once if x is 2. Doing it twice if x is 3. Doing it 3 times if x is 4. So whatever x is, in order to figure out how many times I'm going to multiply 9, I need to subtract 1. So the equation for this is negative 4 minus 9 times x minus 1. Can you turn this into y equals mx plus b? Actually, why don't you turn your paper over and do it on the back of your paper? Okay, what did you guys get?
F of x equals negative 9x plus 5.
Right. Okay, that's what I got too. And that's how I did it. Now, do you remember how to graph a line?
Yep.
Yeah, go ahead and graph that line. Looking at this equation, okay, up here, I know that this is the slope and this is the y-intercept. Okay? So the y-intercept, that means that's where the line is going to cross the y-axis, 0, 5, right here. That point is going to be on the line, right? Hey, take a look at this. That matches with this, doesn't it?
Yeah.
that means we're on the right track. We're telling the same story with our line and our equation as we told with the table. Okay. Now, the slope, right, that's equal to the difference in y's divided by the difference in x's. And in this case, that's -9 over 1. Right? So difference in y's means that if I'm going to change y's, I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1 to the right for a positive 1. -9 over 1, that's my slope. That's my rate of change. Right? That's the other way to think of a slope. My rate of change. For every 1 I go to the right, I go 9 down. Right? Or doing it in slope form, 9 down, 1 to the right. Okay? Yeah?
This all makes sense, but for the -9, how do you know to go 9 down to 9 to the left?
Because slope is the change in y over the change in x, and -9 is equal to -9 over 1.
Yeah.
So this is going to be my change in, this is going to be my change in y. Okay? And when I come over here to change my y, that means I'm going to go down, because y is up and down.
Oh, the -9 is just for the y.
And then the 1
Is for x.
is for x. If this was already a fraction, you know, if this was something like -4/5, then I would go down 4 and 5 to the right. But if it's not already a fraction, you put it over 1, and then it's...
I thought you had to go 9 to the left 9 and go up 1.
Nope. First you go, that's why when we're talking about slope, I keep saying it's the difference in y's over the difference in x's. Okay? It's your change in y from here to here divided by your change in x. Now, all you have to do is find a ruler and draw the straight line. And that line tells the same story as that equation and that table. Okay? That's what we're talking about. Here's what you needed to do to be able to pass the standard. You needed to be able to tell an exponential, know that it was a geometric sequence, that you were multiplying by a common factor. Right? You had to recognize this was linear because it was an arithmetic sequence, and you had to be able to tell me what the common difference was. And for both of those, you needed to tell me what the explicit formula was, the equation like this.